Hello, my name is Dan Seskey, and I'm here to present to you Team BIOS' single plant irrigation system. The irrigation system composes of four major components. If you take a look, we have the main circuit board, which houses our microcontroller. Our LCD display shows us the current state and what the system is currently doing. A transistor, which allows us to open and close the solenoid valve, which you can see here on our dispersal unit, which is connected to a standard garden hose, just for our demonstration. And as you come out the pipe, our dispersal mechanism. Before we go into a full design of the system, let's go ahead and take a look at the main circuit board by itself. Alright, so before demoing the single plant irrigation system, we're going to go ahead and walk through some of the components in the system. So, starting with the power supply, we start with a standard 12-volt power supply, which powers this upper power rail here, which is used to directly provide power to our water solenoid valve. Now, if we come back to the main board, you'll notice here in the upper right that we have a volt switcher, which converts our standard 12-volt supply to a 3.3-volt supply, which is used to power both the MSP430 microcontroller and the New Haven LCD display. Now, also, you'll notice we do have a transistor on the board, which is used to control the water solenoid valve. It is connected to the standard 12-volt supply, as well as another component coming from our MSP430, which tells the transistor when to close to activate and deactivate the solenoid valve. So now to do a little quick demo before we do the main one with the plant, just so we can see the process. You'll notice looking at the LCD display, watering is enabled. So using our Vegetronics moisture sensor, we can then tell the system when we have enough water. So watching now, we are checking and doing water enable. Now if I dip it into water, you will then see the display change, and it will say checking temp. And if you listen closely, you can hear the solenoid valve closing. The LED you notice in the bottom right of the screen is basically just telling us when we are not watering and we're checking the temperature state. Now, if I pull it out of the water slightly, you'll see we're still checking temp because it's still moist enough. So as I come out all the way, you'll see that the light went off and the solenoid valve does open and watering is re-enabled. Now, just to show you, if you notice, if I hold the sensor in my hand and I close, looking at the display, it went to checking temp because my hand is slightly wet. But then you'll notice if I let go, it'll go back to watering enabled. So now let's go ahead and try it on a real plant. Alright, so now that we've seen how the main board works in component form with a brief demo, let's go ahead and do the full system demonstration. Now, one thing you'll notice here on our dispersal unit, we do have this little nozzle with 4 nozzles on top. Now, the original design is meant to work in a standard household with a little reservoir of water that uses gravity to open a solenoid valve mixed with the electrical signals to water the plant. In this demonstration, I'm using a normal standard garden hose, which is providing too much pressure. So what I'm going to do is actually peel this off, but you will still see the water coming out. So now if you take a look at the plant, you'll notice there's this little red sensor inside here, and that is our Vegetronics moisture sensor. That is communicating with the MSP430 chip and telling it when to activate and deactivate the solenoid valve. As of now, if you take a look here at the LCD, it says check. It is right now in the checking state to see if the moisture is going to change. And you can see by the flashing LED there, it's going to constantly do that. So now, what happens if I pull it out of the soil? As of now, the soil is actually too moist due to some prior testing, so it's not going to detect that it needs the water. So what I'm going to do, if I pull it out, and give it a moment, you will now see the water activate. And if you look down at the design here, it says water enabled. And it's going to keep going. And if I plug it back in, and if we watch the LCD there, it'll say checking temp because now it's detected that the water got into the roots and now it's watered enough. And you'll notice the water is no longer coming out of the dispersal unit. Alright, so now that we've completed the entire demonstration, let's go ahead and actually talk about real quick how the MSP430 knows that this plant needs watered. So if I go ahead and pull out the Vegetronic sensor, you'll notice along it we have little tick marks that range from 0 all the way at the bottom, all the way up to 90. So basically what this sensor does is detects water level based on these little tick marks, which is actually perfect for how we want to implement our system. So what we can do is when we put this in, it detects how we've watered it. So when you water a plant, you start with the topsoil, and the moisture actually soaks down into the soil, which is then pulled up by the roots. So when you first water, you actually will be up here at the 90 tick mark, which then provokes this sensor to send 3 volts to the MSP430. As the moisture goes down throughout the soil, you begin to dry from the top of the soil all the way down. So the threshold starts to go down based on where the soil's at. Now, once that this sensor detects the water is too low, it will then tell the MSP430, which will then re-water the plant. Now, the question is, how did we decide when to water it? So we set a basic threshold. If you are below 0.5 volts, you water the plant. If you are above 2.5 volts, you stop watering the plant. If you're in between, you stay in your current state. So now that we've done the full demo and you've seen the component part of the board, I want to thank you for watching. For Team BIOS, I'm Dan Seskey.